Hello, hello. This is Postgres FM, episode number 94. And we are going to repeat episode number 4, but not really. So today we're going to talk about buffers again. So let's call it buffers 2. But I forgot to say hi, Michael.
Hello, Nicola.
Right, I was thinking about buffers already too much. This topic is super important, I think.
Yeah, so last time we called the episode Buffers by Default because you especially, and I'm a convert to this, think that buffers, which is an explain parameter, should be on by default, at least with explain analyze. And there have been a couple of patches over the years trying to put this in place or trying to make steps towards this as a goal. And we were in support of that, but we also wanted to explain why we thought people that are doing query optimization work, so developers, should include the buffers parameter when they run explain analyze manually or with auto explain so that they can more effectively do query tuning. Is that a good summary?
Yes, that's a good summary. Have you ever thought that in explain plans, buffers are not turned on by default, although there is consensus, I think, and the fact that it was not changed so far hasn't been changed. It's only like purely technical reasons, but I'm sure since you checked it, probably you'll explain details here. But don't you find it's interesting that explain plans by default have buffers off, but PGStar statements has it on, right? I mean, just interesting. Why? And because if you want to start connected data, and I think we should do it, we should look at the whole picture, macro level, PGStar statements, and we also should work with individual plans provided by explain command, explain analyze buffers command. And if you forget buffers, just do explain analyze, which many blog posts still suggest, unfortunately. In this case, it's hard for you to connect the dots between the individual plans and macro level.
Yes, an interesting point about PGStat statements. The two, I reread the two threads, the two most recent threads about turning buffers on by default, and the first one was started by Vic Fearing, and it actually was he took a step backwards and said, I personally would like to turn buffers on by default, but because I realized that might not be what everybody wants, and that might be a wider discussion, here's a patch proposing that we allow multiple new parameters for Postgres. Each one was like it was allowing you to turn each explains parameter on or off by default. So set the default yourself for your instance. So you could set buffers on by default for your own instance, and other people could leave it off by default. And that was widely thought of as other people wanted buffers on by default, but because he also included settings to enable and analyze by default and enable every other single, verbose, write-ahead logging settings. I actually can't remember which ones, but basically all of the explain parameters that existed at the time of the thread was started also came with one of these settings. People fixated on the fact that an administrator turning on the analyze parameter by default would lead to you running explain on its own and that executing the query, which was deemed to be a foot gun that would be too dangerous.
Generalization did a bad trick here. And also, honestly, I think it's not I'm not interested in the ability to turn it for specific servers. I want real default for everyone, global default, because I deal with many servers, and I cannot tell them all. This is what we do right now. We tell them all right now. Use buffers by default when you provide plans. It works only partially. It never works. Efficiency here is not 100% the coverage, right? So if we can do it by some additional settings, okay, maybe some cloud providers would do it. I don't know, but it's this partial solution I don't like at all.
I do think we're in a new world with cloud providers. I think now we have this. For example, PGStat statements is off by default, but in the cloud,
Right.
most cloud providers have it on by default. So
And some
for
of
a
them
lot of users,
some of them even learned about template databases, template 0, template 1, right? And put it there. So each new database created. This is how it's implemented, right?
so we're in this new world where we don't necessarily have to have things on by default in Postgres core for it to be on by default for most users in the real world. So there's a slight weird subtlety here. But to move on to the second
But it's still
thread,
partial solution. I want Postgres 18, for example, to have this by default. What should we do? But actually, we jumped straight to this question why it's still not default, but we didn't explain what it is, right? So maybe we should explain first, because it's also important why we care so much about this. Why if a plan doesn't have buffers data, so what, right?
Yeah, let's do a short version because I think we did quite a good job of that in the first episode we did on this.
Okay.
Which we can
Fair
point
enough.
people at episode 4. But do you want to give a short version?
Yeah, let's do a short version. So I see this data, as I mentioned, this data is present in pgstar statements always. So if pgstar statements is installed, you have buffers, shared blocks read, shared blocks hit. There are also local and temp pair, two additional pairs of numbers, but it's not like interesting. Here we will talk only about, let's talk only about the buffer pool numbers. There are also two more columns, dirted and written. So if some query changes data, it's dirted. If it's written out of the buffer pool, it's written. And the hid and read are interesting, of course, because this can give us idea about cache efficiency in terms of buffer pool cache efficiency, because there is also underlying page cache additionally, always still, right? And in the explain plan, if you run explain, it's only the plan. If you run explain analyze, it's the plan with execution. But if you don't put explicitly, you don't put the buffers word, and if you put unit parentheses additionally, so explain analyze buffers in parentheses. In this case, you don't see this buffer data, so you only see timing, and you understand. You cannot, for example, understand cache efficiency in your particular execution of this particular query. How much was taken from the buffer pool, how much was taken outside, maybe from memory, maybe from disk. If it's read, it's outside. You have no idea. Of course, you can enable timing, IO timing, and not regular timing, which is always enabled in the explain plans. Actual timing, right? But if you enable IO timing, this can give you idea about how much of time was spent on IO. And as I understand, like IO in that sense is means IO outside of the buffer pool, right? It's so tricky, by the way. What is IO? Does IO include communication to what? To disk? To memory? Memory what memory? Page cache or buffer pool? Both, or just page cache? In case of track IO timing, this setting, I guess everything but communication to the buffer pool is counted or no?
So. Yeah.
Yes, but I would count everything. So it's tricky. Anyway, you can see timing again, but cache efficiency wouldn't be possible to see. If you're curious, you do need buffers. But in my opinion, cache efficiency is not the number one benefit that buffers provide. Number one benefit is the amount of work. If we know timing, to understand the real efficiency of our mechanism, we need to understand how much work was done. And if we see only number of rows returned, it's of course kind of like, this is final result, right? Delivered. But what's inside? Inside, we need to understand how much actions were needed. And these actions in database world, it's IO. Databases mostly, are all about mostly IO, of course. We don't do a lot of calculations. Usually we deal with IO. The goal is to find the data we need as quick as possible to efficiently change it and write it, store it, and so on. So only buffers can show the actual amount of work that was performed during the achieving final result. And this is again like hit, read, dirtied, written, shared buffers. Of course, temporary files are also interesting if you see temp buffers written and read. And this means that this query needed to deal with work mem was not enough. We needed to write to disk. It's also amount of work, and this can explain some IO timing and overall latency increased significantly, right? So the amount of work. Let's do some maybe new analogy. For example, you need to replace cabinets on kitchen, right? I don't know. And you're not interested in details. Like you need final result. And then you hire some contractor and pay this contractor or like some team, right, of contractors. You pay to them some money. And they say, oh, this took 1 month, right? And you say, well, okay, I see final result. I understand 1 month, I pay. And that's it, bye-bye, right? Is it fair? Maybe it's too much, right? How do we understand that's too much? We can compare to similar cases, but it's better to dive in to understand what exactly are you going to do. Let's check step by step. You will go by this thing, you will put this, you remove something. You start understanding real amount of work to be done. And then you think, really, like you guys spent 1 month for this kind of work? It's like, this is strange. But if in some cases they can really explain, oh, you have difficult case here. You need to change this and that, and this really like a lot of work. And then you start understanding, okay, in this case, probably 1 month is really reasonable, right? Similar in databases. Let's go back to databases. If you see that to return some rows, database needed to perform sequential scan, it's reasonable to have bad latency, very high value, right? Because it needed to scan very big table. It's like a lot of work. And then if it cannot be optimized, of course, yes, we can create index, right? Maybe we can buy tools for our contractors, better tools than they use, and so on. I don't know, but diving inside, this is the key. You understand the work to be done. Does it make sense?
Yeah, it does. I don't think the analogy is great. Like, okay. I think, but I can, like, for example, there's one parallel that could make sense. How many people were working for the month? Like, was it 4 people flat out for a month? Yeah, well, so parallelism is like an interesting analogy there. But I think there's like, you can see all the steps that Explain is doing. You can see what operations it's doing even without buffers.
No. Well, yes, we can see sequential scan or index scan.
Exactly.
But when you see, for example, sequential scan, you see rows. You see an index scan. Okay, you see rows filtered out. But if, for example, let's move slightly to deeper topics. If database is bloated, so to read 1,000 rows, we needed to read 1,000. For example, sequential scan. 1,000 rows, they can be packed in a few pages, or they can be scattered, sparsely distributed to 1,000 pages, right? 1,000 blocks. And you can immediately see, okay, to read these 1,000 rows, we needed to deal with 1,000 pages. 1,000 shared buffers hits, ideally, not reads, right? In this case, you think, okay, something is not good here. Well, there is no data locality here. What can I do about it? Maybe we deal with bloat, or maybe we just need to think about, I don't know, like cluster our data or something. Not very popular choice, but I mean, reorganize physically the order of storage. But this is good. I mean, you can understand, and without buffers, you don't see it, right?
Yeah, well, I mean, I'm completely on board with this. I was just trying to push back on the analogy. Like, we've discussed this before. We both agree it should be, we'd love it on by default. I make a tool where it really benefits from when people use buffers. We give a tip in exactly that scenario when we call it read efficiency, when we say the read efficiency is not good. And it might be bloat, it might be data locality, there might be a different reason. But yeah, you can't spot read efficiency issues without buffers, or other read related issues like read speed. So if you've got bad disks, or you mentioned like being throttled by a cloud provider or something like that, you can't spot that. You maybe can get a clue if you're really tuned into your data volumes and the time being taken. But if you've got the number of blocks or pages and you can convert that in your head to,
Right.
we're reading 100 megabytes and it's taking, let's say, 20 seconds. That's only doing 5 megabytes a second. That is terrible throughput. You've got an idea that
you touched several interesting points here. First of all, sequential scan. If there is like, for example, we have sequential scan, some filters, and limit one. We need just one row. It can be very quick if this row was found quickly, or it can be very slow. It takes a lot of time if it needs to like scan through a lot of irrelevant rows. And without buffers, we have no idea in the plan, right? Because we don't see how many rows we will filter out. Index will report how many rows, how many irrelevant rows are.
You do see rows removed by filter in sequential scan as well.
How come? Filter out. Yeah, okay, sorry. Yeah, you're right. Yeah, okay. But if it's only about. I understand. Yeah, I agree with you. It's only about the cases when storage is not efficient, for example, bloat or dead tuples. This won't be reported, and if we see buffers, we understand. Okay, too many buffers here are present somehow. Let's understand why. And second point I wanted to extract from your speech. It's super important not only to use buffers, but always convert them to bytes. Right? You said megabytes per second.
Yeah.
Buffers per second, it's hard to understand. Usually.
It's also not what disks don't tell us how many pages per second they read.
Exactly. We cannot compare to our disk characteristics. We know usually our random access, sequential access, throughput numbers, maximum numbers, and for NVMe, for example, 2 gigabytes per second, and we understand, okay, we have powerful disks, and like 100 megabytes per second is already very noticeable. But if, of course, memory is much like several orders of magnitude much faster, but if we say how many buffers per second, I don't know. So we need to always multiply it by the size of block size, which is in absolutely majority of cases is 8 kilobytes, right? And I wanted to emphasize this because I think not everyone watched our episode number 4 about buffers.
True.
So I wanted to emphasize how important it is. If you deal with these numbers and you started using them in plans and explaining something, you should understand that your colleagues might not understand you unless you convert it to bytes, to kilobytes, megabytes, or kibibytes, mibibytes, gigabytes. So you start putting these numbers. It's magic. I saw it so many times. It's magic. People say, oh, we are reading 1 gigabyte here for 10 rows. Okay, what's happening here? When we saw like boring buffer numbers, they didn't have such reaction at all. Once they see gigabytes, wow, like this is not. And I had cases when instead of diving deep into some specifics of the plan, it was actually a mistake if you dive deep straight to the details of the explained plan. The number one optimization tip is, okay, guys, how many rows do you want like reasonably to return or changed? And let's see the whole work done by database here. This gives you a very good sense how inefficient it is. And in many cases, it might be some forgotten limit or something, and you understand, oh, okay, this is not what we want actually at all. And this is very high level optimization tip. I see you're skeptical about it, but it works very well.
I don't mind it. I think I've described it. I've heard this described by others and described it myself as the best way of doing work faster is not doing the work at all. So if you can avoid doing it entirely, right, if you can do less work in the first place or no work, if you don't even need to run the query, great, get rid of it. But you're talking about if you do decide you do need to run the query, can you just get are you doing the smallest amount of work that's possible?
So what I think would be good, there is summary in the end of the explained plan.
Yeah.
And in this summary, we should have data in bytes. It would be great to have it. Like how much was read, hit?
I've done this.
Dirty.
It's
and
actually.
I've done this. We both did this with our tools.
Okay. But I think I did it in a controversial way. I did it in a way. I think this gets down to kind of it makes it difficult to the trade-off between being accurate and being helpful. If you're already talking about splitting it into the 4 types, like, I guess there's actually 8. There's actually 10. You've got shared hits, shared read, shared written, shared dirtied.
Yeah.
Local read, local hit.
Right,
so there's 10 statistics already if you want to be accurate about the overall, even the overall reporting. And what we ended up doing is it's horrible and it doesn't make any sense, but it's horrible. Nice from like we just sum them all together and give an overall
it's not horrible.
Number.
If you switch from you need to switch language, and maybe Postgres itself also at some point should switch. Instead of saying shared blocks read in species assessments terminology or hit, what if we would say shared block reads, shared block hits, talking about operations, not the amount of data? Because we both know for hits, for blocks hit, there might be multiple hits of the same block. Many times. Nested loop, for example, very simple case. For reads, it's also possible if I don't know, like it's possible. I think let's not dive in, like let's not spend time here. When you summarize it, instead of blocks hit, I would say how many block hits happened and how many block reads happened, and then you summarize them and say how many IO happened. I would maybe not summarize them all together. I would maybe still distinguish reading and writing types of direction of operation,
I understand, but the reason I love this approach is
I
separately
helpful. I separately of O.
No. The reason I like this is most of the time we're looking at read queries in like that. That's just the general
strange. Case. Don't you have write intensive workloads?
Yeah, of course there are, but if you're looking at people trying to speed up queries, like the vast majority are read queries.
Or they take update and extract the search part of it and optimize it first as select. Maybe. Yeah, it also happens. I agree with you. Yeah.
But my main point was, even if it's a write intensive query, it's the before versus the after. And it's funny that you used the word magic a few minutes ago, that it's the technique that's magic. It kind of flips the switch for people. I think I used that word, but in the opposite direction. I think it takes the magic out of query optimization. I think sometimes junior developers or people beginning think that adding an index is magic, and it's gone. We've seen the blog post. This query is now 10,000 times faster. It's like,
there's no magic here. This is why. Yeah. So let's agree. There's no contradiction here at all. When I started Postgres AI, my idea was that Postgres database administration and optimization and all other areas, it should not be black magic. It should be white magic. And black magic happens when people need to spend 10 years because of lack of transparency of observability tools or regular tools and like understanding good materials. Now we have much better materials than 15 years ago, for example, a lot of good tools. And buffers is one of the cornerstones of tools and approaches which really clarifies everything. And so black magic disappears and only white magic. It's white magic when you say, okay, I did this and now query is 1,000 times faster. It's great, right? But looking only at timing, you cannot achieve it usually. You do need to look at the work to be done or is being done, and this is buffers.
Well, and if you see on the one that's 1,000 times faster that instead of having to read a gigabyte, or instead of the sum of buffers being a gigabyte, the sum of buffers is now 2 megabytes, like something in the order of 1,000, then it becomes obvious.
No surprises anymore. Yeah,
exactly. Yeah. And it doesn't seem magic to people anymore. You start to realize how the index is working and why it's therefore so much faster. Right. So that's the reason I love the simplicity of it. But I think it also, like, I want to get back to, is this now a good time to go back to why adding buffers by default didn't work the second time around as
Yeah,
well.
yeah, please. I'm all ears.
Well, you started the thread.
Yes, maybe I forgot already. Lost. Tests, right? Tests.
Yeah, that was the main. So adding it by default, I think there was one of the problems was the patch the patch set that ended up getting proposed. There were about 4 different patches that all did slightly different things, and I think that was part of the problem, that it wasn't kept as a simple change. And actually, the biggest part of the change proposed was around tests, as you say.
Right.
So if we turn buffers on by default, the first question that you asked and that the patch ended up doing was, should it be on for explain on its own as well as explain analyze? And I think that was a mistake. I think that overcomplicated matters.
Because explain also can have buffers for planning,
yes.
right?
Yes, but the reason I think that was a mistake was it changes, like there are far more explains in the test set in Postgres' regression tests than there are explain analyzes. So firstly, it complicates that. And secondly, timing is off or summary, which gives you the planning time, is off by default in explain. So it's really weird to have buffers on by default and not summary on by default. So I don't think it makes sense logically, but also it complicates the patch set and the regression tests. So if I was redoing this, I would have a go without that. Just have it on for explain analyze, not for explain.
Okay.
Well, that's an opinion. I don't actually know if it'd be any better without it. But the second issue was then, what do we do with explain analyze has timings, right? But they have a regression test setting that turns those off, so that each time the regression test suite runs, the timings fluctuating doesn't make the tests fail. And there was an attempt to add a similar thing for buffers. And
so to disable them for tests only, instead of rewriting the tests. I think, and maybe it's better would be to rewrite the tests, especially because I forgot to mention one of the very good things I like about buffers is that they don't lie, they're always stable. So you can use them in tests and rely. Because, well, of course,
they're not quite as stable as like
hits and reads.
Not just that, planning buffers as well. Like sometimes you get a lot of planning buffers, sometimes you don't. It can depend on the...
Okay, at least to some extent they are stable. Even if the query, for example, is blocked by some different session and is waiting, our session is waiting to a log to be acquired, we can spend a lot of time on this wait. But buffers will be fine. I mean, it won't affect them. And this is one of the signs. If you see buffers are low, but latency is high, maybe locking issues are involved here, right?
Yep. But tests don't, like, they shouldn't block tests passing, right? Like you can handle this a different way.
By the way, I would bring my bad or maybe good analogy back and say, if your guys are wasting a lot of time but do a little work, maybe there is some blocker, right? I mean, with kitchen analogy.
Back to the kitchen analogy.
So I see some analogy here. I see. So
okay.
At least it's my like, I like this approach when you dive deep into details, what's happening, what people are really doing. It can be applied to anything, like maybe lawyers or accountants or something. If you hide, you usually pay more. I mean, if you don't look inside at the real amount of work to be done, you usually end up paying much more. And this is true with databases as well. If you don't use buffers, you will be having inefficient plans and you will need to provision bigger instance, for example, and you will pay more. Same.
Maybe we found the real reason that they won't turn it on by default.
So too many hackers are working at cloud companies and they are not interested. Conspiracy. Okay.
To be clear, I don't believe that.
Yeah, we have one, like, before we finish, because we not much time left, let's touch the very fresh topic, serialize, right?
Sure.
Postgres 17 is going to have yet another option in explain, and it's called serialize, and everyone is excited about that, right? As I said.
I have heard quite a lot of people quite excited about it.
It's good.
I think it is good. Like we're getting the option to see another case where your query can be slow, but explain analyze at the moment won't show that it's slow. So yeah, for sure, good. But again, off by default. And
what serialize is, first of all, just briefly, it's amount of what? What?
Oh, come on.
What?
We're back to buffers, but bytes and
yeah, it's by default
timing.
shows. Right. So timing, bytes, buffers. It shows everything, especially if you have buffers. It will show buffers as well. But what is it about? It's about serialization. So if it can connect us to the last episode when we discussed select star, and I said select star is actually not a bad thing because I was comparing this in my head to the idea to explicitly list all the columns. And select star for me is more convenient way. But of course, if you need only for example, one column, numeric column, for example, integer column, but there is a JSON column next to it, which is toasted. Of course, if you select it, it's a big piece of inefficiency in this query. If you don't need it, you don't use it. But Postgres will need to deal with the toast table. And serialize option can very well show this, right? Like a lot of work to do. Instead of selecting just one number, we need to do a lot.
Well, I think the issue is more that the explain analyze at the moment doesn't show the inefficiency. So if you did select star from that table, you would get a really slow, like you did it from your client, you would get a really slow result depending on how much data there was. Right. You'd see in the client that it was really slow, not just because of there's a couple of reasons. One is because a lot of data is being sent across the wire, but also because of the serialization. So there's two reasons. But if you did explain analyze, yes.
Actually, now I understand that it's pity I didn't see the discussion beforehand because there's a demand actually, and I saw it not once, when people want to see the plan and actual result as well.
Yeah, it's a different conversation, and this is
auto-explain there is, of course, but
yeah, this is only the serialization part, and it's off by default again. Okay. So it's more output. I like it. We can add it to the list of parameters we ask people to use.
You think it should be on by default?
I mean, it's the same argument, isn't it? Like we want to see the actual work being done.
This and that, and also, this off by default, that buffers is off by default. And also analyze is super confusing word because it's used in other areas of Postgres administration. How about having new word invented that will show proper plans? Of course, we can do it in pSQL, for example, with set. /set. And
I did consider, I would be interested in your thoughts on this and listeners' thoughts on the idea of explain all or something, that whatever version of Postgres you're on, it will do all of the parameters.
Explain full.
I think including analyze. Full is loaded for sure, but because of vacuum for, I think. But
all queries? Yeah, okay. Let's not pretend we are hackers at all.
No, but I think there is something to what's the end goal here? Is explain going to have 300 parameters? But how many are we going to keep adding?
Yeah. Yes. So buffers definitely need serialize. I need to taste it myself for some time to conclude. I would say I would have.
I have reservation. I think it's helpful for showing people where the problem is, but because it's still off by default, I think a lot of times when it would have been helpful, it won't be used, which is a shame.
Yeah, that's interesting. Everything here serializes off by default. I actually didn't give this a thought before we recorded this podcast.
It's funny.
Yeah, it's actually it should be default on. Of course, I understand. Someone will say it will produce observer effect, but honestly, I don't care because timing itself produces observer effect. Maybe number one player here, and also this observer effect is maybe not observer effect but actual normal effect because regular clients need this part, right?
Yeah, it's true. This is the opposite. The observer effect, normally we're talking about the additional timing added by observing, whereas this is a case where explain analyze will underreport the time taken because of this.
Skipping some work that is needed actually. weird. So I need to, my fingers need to memorize. By the way, I type explain analyze buffers super fast. Now I need this as well serialize. It's already too much.
I actually now use a text expander. So every time I can type explain analyze and it will change it to the full list. But obviously you need to work in lots of different terminals all over the place. So
yeah.
Probably best to learn to type fast.
Anyway, okay. So we like the thing, but don't like its default off. Maybe we should actually
That's my opinion.
The reasons. Yeah. Okay.
It probably makes the test difficult.
Of course, that's difficult. Of course, but yeah, I would emphasize once again in tests, in regular tests, application tests, buffers is a gold, because I understand that sometimes there may be slight differences because, for example, data is packed slightly different if physically, right? Layout is slightly different, but there is no order of magnitude difference. With timing, you can have it. Disks are slower and saturated, disk IO is saturated, or locking issues, something like that. And you have timing which you don't understand. With buffers, it's reliable number you can use in testing. So
cool. Thanks so much, Nikolai.
Thank you.